Hi, this is Mrs. Dubois, and I am going to deliver the notes for today. And we are looking at solving systems of equations by multiplying. The goal is to find the solution to a system of equations by eliminating a variable using multiplication. So we're going to think about what we did last week with using addition and subtraction to eliminate a variable. But this week we're going to have to add one more step in manipulating one equation or both equations via multiplication to wipe out or eliminate a variable. Let's take a little walk down memory lane. Oops. And we're going to look at something from a long time ago, and it's adding or subtracting fractions. And to add or subtract fractions, you need a common denominator. Okay, and we're going to look at two problems. If I were you, I might stop this video, try these two addition problems of fractions, and then turn the video back on and follow along. Okay, so we need a common denominator, and we can see that if I multiply 2 by 2, I will get 4. And so let's use the common denominator of 4. And because I multiplied the numerator, 2 times 2 to get 4, in order to maintain equivalency, I have to multiply the numerator. 2 times 1 is 2, and then this 1/4 is already set up, common denominator 4. Then we're going to apply the rules for adding fractions. We add the numerators. 2 plus 1 is 3, and then we did all this work to get a common denominator, and so we keep it 3/4. All right, if you take a look at 1/3 plus 1/2, the common denominator is not as obvious. We have to multiply both fractions by something in order to get a common denominator of 6. So in the first one, I multiplied 3 times 2 gives me 6. And I have to multiply the numerator by the same number. So I have 2 6. And then here, I have to multiply both the numerator and the denominator by 3. Again, we're going to apply our rules for adding fractions. 2 plus 3 is 5, and then we keep the denominator. So we have 5/6. All right, so we're moving along closer to solving systems of equations. So in these two, in order to add fractions, we needed a common denominator. And now, like you make equivalent fractions, we're going to look at making equivalent equations, okay? So we're going to take 2x plus 3y equals 6, and I'm picking a random number, 2. And I'm going to multiply 2 by everything, okay? So I get 2 times 2x is 4x, plus 6y equals 12, okay? And what I am showing you here is that this equation is equivalent to this equation, all right? So if I wanted to apply it, you're thinking this fraction, 2/4, is equivalent to 1/4, all right? So let's take a look at it. This next example, 3x plus 5y equals 2, and we can make it equivalent equation. And again, I'm just going to pick a random number, -4, and I'm going to multiply -4 by everything in this equation. And I'm going to get -12x minus 20y equals -8, okay? Again, driving home my point that this equation is equivalent to this equation, all right? Now, we're moving to example 1. If we were to add these equations, would we eliminate a variable? If we put a plus sign here, can we add these two equations and eliminate a variable? No, because 5 plus 3 is 8, and 2 plus -4 is -2. So just by simply adding, we do not eliminate a variable. Now, if we subtracted them, do we eliminate a variable? No, upon examining that, if we subtract those equations, we do not wipe out or eliminate a variable. So getting back to equivalent equations, can we multiply one of these equations so that the coefficients match, allowing you to add or subtract to eliminate, all right? And you're still connecting it back to equivalent equations and the idea of how you get equivalent fractions, okay? So we have my 2 and my 4 again. So I can multiply this equation by 2, right? Everything, to multiply everything in here by 2. So that's 10x plus 4y equals 32, okay? And then I don't have to do anything to the bottom equation, but rewrite it, okay? So just for my own purpose, I'm going to extend that line. So in order to wipe out the y's, I can add these two equations. So I'll have 10x plus 3x is 13x. Positive 4 plus a negative 4 is 0. So these eliminate or wipe out. And then I have 32 plus 20, which is 52. Oh, I have a one-step equation. I'm going to divide by 13. And x is going to be equal to 4. So I have half my answer. Remember, we're solving systems of equations, so we need an ordered pair, okay? That's a 4. Now, you should go back to the original equation to plug in your x. And I'm simply choosing this one because the coefficients are a little smaller, but it does not matter if you choose the first or second line. And I'm going to plug in 4 is equal to x to find what my y value would be, okay? So if I evaluate, this is 12 minus 4y equals 20. Subtract 12 from each side. I get negative 4y is equal to 8. Divide this by negative 4 and get y is equal to negative 2. And I'm going to put that over here with my ordered pair. So 4, negative 2 is my answer. If you wanted to do something really unique, you could put this one equation and this equation into Desmos and double check. And in fact, your answer would come out to be 4, negative 2. All right, let's move on to page